All right, welcome to physics today. Over the weekend, you should have completed the activity about linear patterns, where on Friday we introduced y equals mx plus b to help us make predictions. And so, what I learned from Friday during a student poll in our Zoom sessions was that we might want a little practice with solving for variables. And so this week I've broken it down where we're going to be solving for distance, solving for time, and then solving for velocity. And then let's get started. So solving for distance, I've got the slideshow here again. This is a little reminder on how y equals mx plus b relates to our experiment and so forth and collecting data in science. Again, we're probably more familiar with this from math class in the past. And this is the equation for a straight line. But with our data in this distance versus time relationship with a constant velocity, um, it is a linear relationship. So we can use this to make predictions about the future. So again, our y variable is distance. So in today's activity, you'll be solving for y. And then you will be given your velocity, which is your slope, okay, velocity. And then you'll be given your time. And in some cases, you'll be given your y-intercept, which is really your starting point, right? So if the person or object starts at kind of a current position, we might refer to it as zero. But you could also make predictions if an object is starting, 10 meters away. And then so you would insert that as the starting position. Okay, next, what you will know or need to know in order to solve for distance is time, velocity, and then again, starting distance. And if it doesn't mention it, assume zero. So, little example problem here. I could give you the time, give you the velocity, and you don't know the starting distance. So again, you assume zero, and you're trying to solve for distance. So if I have time, which is my x, at 200, and my velocity is 1.5 meters per second, I answer 1.5. I do the math. Again, when there's no symbol between two variables, that implies that there's a multiplication. And then when I write the numbers, I will add the parentheses, to show that there's two separate numbers. And again, with no symbol in between the parentheses and the other number, you will then multiply that. Okay, so 1.5 times 200 equals 300 plus 0. So our y equals 300 meters. Don't forget to include the units. And just for the record, your velocity is going to give you the units for your distance. So this might not always be meters per second. This could be miles per hour. It could be kilometers per hour, something like that. So you want to make sure you use the same unit of distance that is included in your velocity. Another example, you might have a word problem. So in this word problem, Diego watches a thunderstorm from his window. He sees a flash of lightning bolt and begins counting the seconds until he hears the clap of thunder 10 seconds later. Assume the speed of sound is 340 meters per second. How far away was the lightning bolt? So again, the speed of light is much, much faster than the speed of sound, but we've got the speed of sound, that's our velocity, and we've got how long it took. So we could then determine the distance of where that originated from. And then before it got to his ears, Diego's ears. So we plug in time is 10 seconds. We then have 340 meters per second. So 340 times 10 equals 3,400. So our distance is 3,400 meters away. And again, I included that because that was the question, how far away? Another point I wanted to make in the previous problem, I mentioned you want to make sure you use the same unit for distance from your velocity. You also want to make sure that your time and your velocity agree with one another. So this is 10 seconds, and this is 340 meters per second. So again, the seconds are the time variable, agree and need to agree. In the case that you have different units, maybe this says 10 minutes. Okay, that'd be extreme for this situation, but 10 minutes, and this is per second, well, you would need to convert the minutes into seconds. Now you're going to go ahead and try. So below, I've got practice problems. I'm going to give you a time and velocity. You solve for distance. I would like you to quickly show your work, or if you need to kind of work it out, similar to what I did here. Kind of plug in those numbers so that if you make a mistake, I can see where the mistake occurred. Again, time and velocity. Okay. Seconds and minutes. Again, you're going to have to do a time conversion to make sure that they agree with your velocity. Kilometers per hours and hours. Okay, so you're going to double check minutes, kilometers per hour. Ooh, I've given you a starting distance here. So really make sure you plug in those numbers appropriately. And then we have a few word problems, or just a couple word problems. Okay, again, I'd really like you to show your work and plug in those numbers into our equation y equals mx plus b. Let me know if you have any questions.